Okay, the title of my presentation today is about how we at Urban Utilities used FME Server as a real-time gatekeeper for business enterprise GIS data. My name is Tim Jones. I'm a senior GIS analyst at Urban Utilities. To give you an overview of what I'm going to present today, we'll start with the objectives and the challenges, and I'll go into a bit of the solution and provide some tips, and then the conclusions and where to from here for Urban Utilities. So data collaboration, as most people know, is essential for business to make the right decisions. Real-time data collaboration allows businesses to make better decisions sooner. So this solution is all about real time. The previous solution we had at Urban Utilities for work requests and work order data was this data was created outside of GIS in the asset management system, and then on a scheduled task that data was geo-processed and moved into the web GIS as read-only. The 2B solution that we worked on and have working currently is the other way around. We use WebGIS to create work requests and work orders on demand, and we use FME Server as a tool to dispatch that data to asset management. And then the two systems, GIS and asset management, are in sync in real time. We also had another objective, which was to allow users to of the WebGIS to get real-time SCADA data into the GIS on demand. The challenges we faced was how do we go from using FME Server that, like most people do, as scheduled jobs or automated jobs, how do we get it to be used as a real-time gatekeeper? And the answer to that is basically using FME Server webhooks in conjunction with our enterprise integration, our API gateway. So the next few slides are going to detail our solution for these two objectives. So the first objective, how do we put all this together? How did we use FME Server to keep our GIS and our asset management system in sync in real time? So step one for that, we use the GIS to capture and validate work request details as they come in real time. We persist that data to the staging database, and then we call FME Server synchronously via a FME Server webhook, passing the required parameters to server. An example of that URI is below on the slide. Step two. This is the FME Server doing its ETL, so it receives the request with a parameter. It uses that parameter to read the persisted data. It transforms that data into a JSON format, calls the API gateway synchronously, passing that payload, that JSON payload, waits for the response, gets the response, extracts the JSON from the API gateway, and persists that data in the database. That's step two. Step three, back to the WebGIS. It's been waiting for that synchronous call, the response for that call. It will confirm to the user the success or otherwise of that call, and it will query then and display that data in the GIS. And at that moment, the two are in sync. The GIS and the asset management system are in sync. So that was the first objective. The second one, this is the idea of getting some SCADA data in real time. So the user selects in the WebGIS a required monitored asset, the one they're interested in, and makes a call to FME Server, passing a parameter representing that asset. And again, the URI example is below. Step two, the FME Server does what it does very well, which is ETL. So it reads the parameter that's been passed. It calls the API gateway again synchronously, passing that parameter as a payload, and it waits for the response. When it gets the response, it writes the JSON back to the caller. Step three, the WebGIS gets the response, It receives the payload from the FME server call. It unpacks that payload and displays it to the client. So that's the client then getting real-time data in a WebGIS from outside via FME server. So those were our two objectives and how we did those. A couple of tips and tricks that we worked through and came up with. For the WebGIS calling FME server, we found it advantageous to keep the payload very simple, usually just a single parameter or a small number of parameters, and persist that data in the WebGIS and say, here we are, FME server, use this parameter to re-query that data. And also to call FME server, make it a synchronous call. For FME server calling the API gateway, again, a synchronous call. Ensure the API gateway handles all the replay requirements if under certain different error scenarios. But likewise, the FME needs to cater for those scenarios and report back to the caller, to the WebGIS accordingly. Okay, the results, FME has allowed us to create critical data in GIS and share with other business systems in real time. On average, we do currently 100 work requests and 100 work orders daily through this solution. In times of crisis like the recent floods, it can be double that. FME server has allowed urban utilities to consume real-time data, and the example I gave you was the SCADA data. The benefits of using FME server for this solution, we find it's if you know how to use FME, and a lot of people here would do, it's a short learning curve. It's relatively straightforward to do. It's easier for us to provide support for an FME server solution than some low-level code. For the users, it's a single, easy to use spatial interface, which they like, and we've got a lot of positive feedback from the call center users on this. So in conclusion, FME has proved a very successful real-time gatekeeper for us for our enterprise GIS, and it's relatively easy to do so, and it's proved successful for us. There's a link there about webhooks and FME server that we found useful. The next steps for us at Urban Utilities is to look to replace the legacy integrations that we currently have and replace with an FME server-based solution. And also to allow non-GIS applications to request data from GIS and also supply data to GIS using FME server. Thanks for listening. I hope you got something out of it.